Hi, my name is Ellen Litkowski, and I'm a fellow at the Office of Planning, Research, and Evaluation. In this video, I'll give you a quick summary of the Bayesian Interpretation of Estimates, or BASIE Framework, which was devised by Mathematica researchers John Deke and Finucane. It was presented at OPRE's 2017 methods meeting, called Bayesian Methods for Social Policy Research and Evaluation, and later published as a brief. BASIE stands for the Bayesian Interpretation of Estimates, and the BASIE framework describes one alternative approach to traditional null hypothesis significance testing. One challenge facing researchers is that null hypothesis significance testing can lead to misinterpretation of and overconfidence in a study's results. Too often, when an evaluation reports a statistically significant impact estimate, readers mistakenly believe that there is a very high probability that the intervention works. Similarly, when the evaluation fails to find a statistically significant impact, readers believe there is a very low probability that the intervention works. But p-values actually tell a different story. Specifically, the p-value of a null hypothesis significance test tells you the chance of finding the observed effect when the true effect of the intervention is 0. However, what most people actually want to know is the chance that the intervention meaningfully improved outcomes. These two things may sound similar, but they can be very different. The BASIE framework offers an alternative approach to interpreting impact estimates that directly answers that question, the probability that the intervention moved the needle. Using the BASIE framework, a researcher should estimate the probability that an intervention worked in a way that takes into account both the impact estimate calculated from study data and prior evidence on the effectiveness of generally similar interventions. Since prior evidence, or priors, might be imperfectly matched to the intervention and study at hand, authors Deke and Finucane recommend reporting 2 point estimates for the impact, both the traditional impact estimate based only on study data and an estimate incorporating prior evidence. In addition, they suggest always using prior evidence in the interpretation of the findings. Finally, given the challenges of specifying the relevant priors, the BASIE framework recommends conducting and reporting the results of sensitivity analysis, which considers a range of plausible priors. Through sensitivity analysis, a researcher could say something like, the probability that the intervention improved outcomes by at least 0.2 standard deviations could be as low as 64% or as high as 91%. That said, using the BASIE framework may present its own challenges. Specifying relevant priors can be difficult for interventions that are very different from those that have been previously studied, and misinterpretations of the results of the analysis using Bayesian methods are still possible. And of course, neither traditional significance testing nor the BASIE framework can fix fundamental problems with an evaluation's design, data, or analysis. In short, the BASIE framework may be a helpful approach for researchers who want to respond to policy and program-relevant questions in ways that are credible, easily understandable, and therefore actionable. To learn about the BASIE framework in detail, find the brief describing it and other innovative methods topics, please visit opremethodsmeeting.org. Once there, look for our materials related to our 2017 meeting, Bayesian Methods for Social Policy Research and Evaluation.